Hello guys, this is Paul once again, and there's something I want to show you concerning these power supplies. Sometimes they do have dirty power. That's power with the ripples. I'm going to compare these two. This one is okay. This one is okay. This one is problematic. So there's something like a DIY control panel. Then I have an oscilloscope here, Frenzy, some cheap oscilloscope. Oh, forget about my messed up table. But I want you to focus on something very important. Right here, I'm running an Arduino, like a Arduino code at Mega 328, and I want to power. I'm powering it through this 12 volts. Switch mode power supply comes in 240 volts and then comes out 12 volts to power my control panel here. So when I turn it on and the stuff turns on, just wait and see. I haven't pressed anything, it's pressing itself. Why? Come on. It's pressing itself. This sounds like magic. Come on. Why does it sound like magic? It's magic. Abracadabra. Abracadabra. It's pressing itself. See. This is weird. This is what we call some sort of EMI. Coming from this guy. So we're going to power up this guy so that we hook up this guy to this guy and see the difference. See, you can hear the beep. I believe the beep is when you press the buttons, when you key in something. So let's get started. Let's now hook up the other guy to see the difference. Now when the other guy is hooked up, let's see the difference. Something to note is that these power supplies have the same specs despite the size. You see it's a 12 volt output, 5 amps, and same for these. It's 12 volts output, 5 amps. So let's check what happens. Let me power it up. Oh, yes we go. Come on, come on, come on, come on, come on. Okay, good. So, see this power. The display is getting on. Let's see if it's gonna press itself. It's not. Sorry for shaking the camera. I'm just an amateur. Okay, now you can do. It's amazing. So you see there's nothing. There's no terrible EMIs causing the system to press itself continuously. That's very annoying, especially if you're doing some projects which are sensitive. This can be very frustrating. So when it's so frustrating, you have and then you'll be wondering what's the problem. Is it your software? Is it your firmware you're running, like maybe in Arduino, or you're having a problem with your dirty power coming to the chips. See, these powers coming to the chip and then create some problems with your hardware. So let's check this on the oscilloscope and see what's the difference. So I'll hook my ground here and I look my probe there. Now let's look at the oscilloscope. It's telling me. Let's try it once again. Okay, set to origin. Nice. You see The oscilloscope is saying, hope you are seeing very well. 12 volts, and then let's zoom in a little bit. No, the divisions are something at 20 microseconds, and let me raise the time a little bit to 10 nanoseconds. So you see the power is quite clean. It's clean. It's clean. It's clean. It's clean. As I said again, these budget oscilloscope, so don't expect something fancy. But you see a lot of these are details there. You see the power is not super dirty. Even if I'm running at 10 nanoseconds, that's the max of this oscilloscope. The Finzi, I don't know how you pronounce that, or Finisi, whatever. So now, this is for the guy who say to be okay. Now let's check the other guy. This one, the bad one. Let's see if there is any problem with these DC. You see this DC, so there should be no some sine waves or whatever waves. Should be some nice smooth line, especially if you go the lower. Let me sample it. Let me go to 5 milliseconds. You see 5 milliseconds, it's very stable. There's just a good line. When you go high lower, you see a line being redrawn every time and again. That's 100 milliseconds. 100 milliseconds division. So now you see it. Okay, let's go to let's check out this guy. The guy, power it up. I powered it up. Already you see it's picking some little bit noise there. Let me turn this off. Let me remove let me rehook up these. Will be this one. I'll take it to the ground, and then this to this positive. Now look at that. Let's even check it afresh. Origin. See the difference for yourself? It's still 12 volts, but and I'm doing at 50 milliseconds. Let's go higher. I'm now doing 500 milliseconds. You see there's a lot of noise. That's why you hear the beeping. So let's go to 5 microseconds. Let me go up a little bit. Now you see that it should be DC. Now you're seeing the waves. That's there's a lot of ripple. There's a ripple there. So this is what's causing your problems, injecting your problems to your microcontroller like the Arduino. So it's good to be careful about such situations. See that wave? I'm now doing it at 10, okay, not 10. These are mere 500 nanoseconds. So, but you see how the problem is big, and the division is 10 volts. So if you go higher divisions like 5 volts, you see when we go moves faster, and then yeah, you see how it's big. at 2 volt division. This is pathetic. This is so pathetic. So if I hook the other one, I switched it off. Switched it off. Let me now switch it off. Let me hook up the wires to the other oscilloscope. You see the difference once more, like what I'm saying. You just see for yourself. Same settings, same settings, same settings. I haven't touched the oscilloscope. Same settings. You see, this is a continuous line. Now again, same settings. Let's go back to see to the other guy. Let's go back and see what happens. Oh yeah. Same settings, nothing touched. 250 nanoseconds, everything constant. Technically, if the power is okay, there could be the same results, because these things are technically the same. They have the same specs. So you see, that's why the other one is misbehaving, the other one is not misbehaving. Okay, thank you for watching my video, and hope you learned something about this DIY engineering. And if you have any questions, you can write in a comment on my section there for more details. Okay, thank you, bye.